Hello, my dear students, and welcome back to this uh, videos lecture series by AKTO. I am Dr. Supriya Farlatpam, an assistant professor in the Department of Civil Engineering in Vav Banarsi Das Institute of Technology and Management, Lucknow, and I will be taking Unit 3 for Environmental Engineering KCE 603. And I have already given lecture 1 and this is our lecture 2 on Unit 3. So, as already discussed, Unit 3 is on physical, chemical and bacteriological examination of water and wastewater, and we are on the we have in my lecture first lecture I finished physical characteristics of water. Now, today in my first lecture we have talked about the chemical characteristics of water, and now we are in chemical characteristics of water. In chemical characteristics of water, we will be talking about total and suspended solids, the pH value, hardness, chloride content, nitrogen content, phosphorus content, fluoride content, iron, manganese and other metal content, and dissolved gases. So, we will be talking about all of these characteristics one by one. So, firstly to the total solids and suspended solids. So, total solids and suspended solids, I have already talked about suspended solids a little bit in the physical characteristics, and that time I have told you we will be focusing more of it in the chemical characteristics. So, the total solid test quantifies all the solids in water, so either be it suspended and dissolved or organic and inorganic, right. This parameter is measured by evaporating a sample to dryness and weighing the residue. So, what do you mean is that if you take a water sample and if you simply keep it outside, or if you dry it in the sun, or somehow you evaporate all the water, what will happen? Water molecules, whatever pure water molecules will be evaporated, and what will be remaining will be the solids which will be present. So, total solids can be expressed in milligrams per liter on a dry mass of solids basis at drying temperature slightly above boiling point. Okay, that is boiling point is 100, here you have to dry at 104 degree centigrade, is sufficient to dry off the liquid and the washer absorb to the surface of particles, while at a temperature of 180 degree is necessary to evaporate the occluded water. Suspended solids can be found by filtering the water sample and weighing the residue left on the filter paper. So, what we will do? You will simply filter the water, and whatever will be left on the filter paper will be the suspended solids. What will pass from the filter will be the dissolved solids. So, what we will have here? You have the filter paper. If you pour water on this, whatever will be left will be suspended solids, and what will pass which will be in the which will already will be in the water will be dissolved solids. Okay. The difference between total solids and suspended solids will give the dissolved solids. As already discussed before, acceptable limit is of total solids in potable water is 500 ppm, and the permissible limits, that is the limit after which we would not be accepting that water will be 2000 ppm as per 1050 10500 2012 code. So, before we move any further, I want to say something. See, I think most of you must be writing that people are writing ppm and also milligram per liter. Okay. So, sometimes I will write 500 ppm, sometimes I will write 500 milligram per liter. So, what is it, right? These are all units, right. So, what is ppm? ppm is parts per million, right, and what is milligram per liter? That is the amount of the how much of a milligram is there in 1 liter. Okay. So, let us look at something else here. Say for example, for water for water ppm and milligram per liter are same. So, here what if you I want to say here 1 milligram per liter, in the sense that 1 milligram per 1 liter, right, 1 milligram of solid or total solids in 1 liter. So, what is 1 milligram? 1 milligram 1 liter of water. So, what is the weight of 1 liter of water? 1 kg, right, 1 kg. So, 1 milligram divided by 1 kg, in the sense 10 to the power 6 milligram, right. So, what is this? 1 part, and here 10 to the power 6 part, right, that is 1 ppm, right. So, that is how you get it from 1 milligram to 1 ppm. How you get it? 1 milligram per liter will be 1 milligram by divided by 1 liter, right. So, 1 milligram, 1 liter of water, how much is the weight of 1 liter of 1 liter of water? 1 kg. Convert this kg into milligram, 10 to the power 6 milligram. Then which is, so what does it mean? 1 part, if you take 1 milligram as 1 part, then 10 to the power 6 milligram will be 10 to the power 6 parts. So, 1 ppm, right. Now, we are coming to the pH value of water. pH value of water is one of the most important chemical characteristics of water. Okay. So, pH value, what is pH value? pH value indicates the log of reciprocal of hydrogen ion concentrations present in water. Thus, it is an indicator of the acidity or alkalinity of the water. pH equal to, that is pH will be equal to minus log base 10 of hydrogen ions. So, here it is base 10, please remember it, it is not natural log, it is base 10. So, what does it mean? It means that pH will be equal to 1 by log hydrogen ion, right. So, if I say a pH of 7, a solution has a pH of 7, then what does it mean? It means that log 10 hydrogen, what does it means? That pH equal to 7, that is minus log 10 hydrogen ion, means log 10 hydrogen ion equal to minus 7. So, concentration of hydrogen ions will be how much? This is 10. So, 10 to the power minus 7. So, if a solution has a pH of 7, then it has a concentration of the concentration of hydrogen ions in that solution is 10 to the power minus 7, or if it is 9, 10 to the power minus 9. Okay. So, a pH less than 7 indicates acidic solution and a pH of more than 7 indicates alkaline solution. Acidity is caused by presence of mineral acids, free carbon dioxide, sulfates of iron and aluminum, etc. in water. And here we are also going to talk about alkalinity. I am highlighting this in green because this is actually related to a part which we are going to study in the next section. Okay. For the time being, please understand only this much, that alkalinity is caused by bicarbonates is called bicarbonate alkalinity, that caused by carbonates is called carbonate alkalinity, and that caused by hydroxide is called caustic or hydroxide alkalinity. pH of water, it can be measured with the help of a potentiometer, which measures the electrical potential exerted by hydrogen ions, in this thus indicating their concentration. The permissible value for public water supply, that is for potable water, as per IS 10500:2012 is 6.5 to 5 to 8.5. So, if a water has a pH of 6.5 to 8.5, then it is drinkable or it is potable. Acidic water may cause tuberculation and corrosion, while alkaline water may produce incrustations, sediment deposits, difficulties in chlorination and certain psychological effects on human system. Now, let us come to a very important part of the chemical characteristics of water, that is hardness of water. So, what is hardness of water? Hardness in water is that characteristics which prevent the formation of sufficient latter or foam when mixed with soap. So, you people must have observed that certain this thing certain water, even if you keep on rubbing soap, then you won't be able to form a you won't be seeing any latter or you won't be seeing any foam. That means that that water is hard, right. So, what is so for this if it is it is soft, then you will be able to see lots of foam, lots of latter. Okay. Now, what is hardness? It is defined as the concentration of multivalent metallic cations in solution. So, multivalent metallic cations, right, those are metal and cations in solution is generally caused by the presence of calcium and magnesium salts present in water. Why? Because these are the most commonly common cations which are present in water. Okay. So, this calcium is commonly present in water, magnesium is commonly present in water, that is why this is and that is why there are other metallic metals also cations also which cause hardness of water, but their contribution is actually very less. Hard water are undesirable because they may cause greater soap consumption, right. जैसे आप कपड़े धोते हैं तो क्या होगा, अगर हार्ड वाटर में कपड़े धोएंगे तो साबुन का झाग निकलेगा नहीं, तो यू विल कीप ऑन यूजिंग द सोप अगेन एंड अगेन एंड अगेन एंड ऑब्वियसली योर सोप कंजम्पशन इज गोइंग टू इंक्रीज. ओके. स्केलिंग ऑफ बॉयलर्स, हार्ड वाटर में इफ़ यू यूज इट फॉर बॉयलर वाटर, जो बॉयलर की साइड में इंक्रस्टेशंस हो जाएगा, राइट. देन cause corrosion and incrustation of pipes, and it can also make food less tasteless. Food tasteless. Okay. Hardness is measured as calcium carbonate equivalent of calcium and magnesium ions present in water. ठीक है, present in water expressed in milligram per liter. So, total hardness in milligram per liter as calcium carbonate is what? Equal to calcium ion into combining weight of calcium carbonate divided by combining weight of calcium ion plus magnesium ion into combining weight of calcium carbonate divided by combining weight of magnesium ion. The combining weights which you have to use here is 20, 12 and 50. So, for example, so what I am saying here, so what here is, so this is 20, this is 12 and this amount is 50, right. So, the combining weight of calcium here is 20, combining weight of magnesium is 12 and combining weight of calcium carbonate is 50. Okay. So, here what you have to do, you just have to put the concentrations of calcium ions and the concentration of magnesium ions, and then you can get the total amount of hardness in calcium carbonate. Now, as I already told you that we have to discuss alkalinity. We cannot discuss alkalinity alone or hardness alone. We have to discuss alkalinity and hardness together. Okay. So, why is it so important? What did I say to you about alkalinity? Alkalinity, I said, was due to presence of bicarbonate, carbonate and hydroxide. Okay. This part is comparatively less, so we will cancel it. Okay. And what did I say? Okay. Hardness, what is hardness? Hardness is due to presence of calcium and presence of magnesium, right. So, this calcium and magnesium, they are going to react with this bicarbonate and carbonate, and what they are going to form? Calcium is going to react with bicarbonate, form calcium bicarbonate. Calcium is going to react with carbonate and form calcium carbonate. Calcium is going to react with magnesium is going to react with bicarbonate, and what magnesium bicarbonate, and magnesium is going to react with carbonate and form magnesium carbonate. So, all these things, what are this? These 4 items, they are going to, or these 4 chemicals, they are going to contribute to both alkalinity and hardness, right. So, this is also going to cause hardness, this is also going to cause hardness, this is a part of hardness, this is a part of hardness. At the same time, this is also going to cause alkalinity, a part of alkalinity, a part of alkalinity, and a part of alkalinity. So, we cannot see alkalinity and hardness alone. And the same, okay. Now, what did I say again, that okay. Now, let us come to the next part. We will be coming back to this part again, but for the time being, let me move to the next slide. Now, we are coming to the most very important part of chemical characteristics of water, that is hardness of water. Okay. So, hardness, we have already talked about hardness, and hardness can be classified into 2 main types. One is temporary or carbonate hardness, which is due to the presence of bicarbonate and carbonates of calcium and magnesium, right. So, what is here? Carbonate hardness is due to bicarbonate and carbonates of calcium and magnesium. Now, let us go to the previous slide. Okay. We have talked about a slide. What was that? What was what we just read? That carbonate hardness is due to the presence of bicarbonate of calcium and magnesium and carbonate of calcium and magnesium. So, what do we see? We see that whatever is causing alkalinity is also causing carbonate hardness, right. So, this hardness is carbonate hardness. So, carbonate hardness is related to the alkalinity. So, whatever is causing, whatever chemicals is causing alkalinity is causing carbonate hardness. So, you can say that in most of the cases we will have carbonate hardness will be equal to alkalinity. Okay. We will talk more about it in the next slide here. And another is that permanent or non-carbonate hardness is due to the presence of sulphate, chlorides and nitrates of calcium and magnesium, right here. So, carbonate and bicarbonate is due to is causing temporary bicarbonate and carbonate of calcium and magnesium is causing carbonate hardness, and sulphates, chlorides and nitrates of calcium and magnesium is causing non-carbonate hardness. This temporary, why is it called temporary? Because it is actually very easy to remove it. So, it can be easily removed by simply boiling or adding lime, and for non-carbonate hardness we require special treatment like softening. As we can already see here, total hardness will be equal to, obviously will be equal to non-carbonate hardness and hardness, and carbonate hardness, as I already discussed, is the minimum total hardness or alkalinity. If alkalinity is less than total hardness, carbonate hardness equal to alkalinity. If alkalinity is more than hardness, non-carbonate hardness is equal to 0 and carbonate hardness is total hardness. Hardness can be measured by directly titrating with EDTA using Erychrome black tree as indicator. Acceptable limit is 200 ppm and permissible limit is 600 ppm for both hardness and alkalinity. Till here we have finished hardness of water. Thank you my dear students, and let us meet for the next lecture after some time. Thank you.